In this episode, we will see about the process wastewater treatment, types of influent and chemical use. We can see laboratory waste and dam water plant wastewater after neutralizing, and the process waters, rainwater collected in the stormwater drain from various process wastewater from various units like wastewater plant, wash water, water drain after usage from process units, oily water from the compressor and pump area, and other water is coming from wastewater treatment plant itself after recycling. And the general four contaminants are organic, inorganic, radioactive, and acid or base influent. The chemical used are sulfuric acid and sodium hydroxide for maintaining the pH, then urea and TSP as nutrients. Nitrogen is needed by all organisms to form proteins to grow and reproduce. Phosphorus is also a nutrient needed by all organisms for basic biological processes. Cationic emulsion polymer is added in flocculant tank to separate solids from liquid and help sludge formation. Another type, anionic powder polymer, is added to settle metal oxides, chrome, cyanide removal, and clean this effluent from automatic oily waste treatment process. One of the polymer will be selected based on the influent impurities. Then the antifoaming agent is either glycol or polyol or vinyl is added when foaming is there, and the polymer is added in thickening unit. Now we can see the impurities present in the wastewater and the plant load. High levels of nitrate along with phosphate can overstimulate the growth of aquatic plants and algae present in water, causing high dissolved oxygen consumption, killing aquatic organisms. This process is called eutrophication. Nitrate, nitrite, and ammonia enter waterways from fertilizer runoff, industrial wastewaters, and sanitary wastewater. This will affect the organism growth. And then dissolved oxygen. Oxygen enters the water by direct atmospheric absorption or by aquatic plant and algal photosynthesis. Oxygen is removed from water by respiration and the decomposition of organic material. So this will reduce the dissolved oxygen. When bacteria breaks down this organic material, measured as biochemical oxygen demand, use the oxygen to dissolve in the water. All water inhabitants and microorganisms cannot live when dissolved oxygen level drops 2 to 5 parts per million. So when BOD level is high, the DO will come down. Biological wastewater treatment plants are designed and operated on the basis of oxygen demand, either BOD or COD, received and removed. Accurate information on the influent BOD or COD concentration and volume is therefore essential to treat the wastewater. Suspended solid in the influent and the new solid made is equal to change in mixed liquid suspended solids plus solid in surplus sludge and suspended solid in final effluent. This will decide the wastewater treatment biological treatment process. Now we can see the treatment process. Almost 90% of wastewater treatment plants utilize the activated sludge process. The wastewater collected in a basin called retention basin are to be chemically treated and physically prepared to develop the natural bioreaction to digest pollution by means of chemical dosage and biological growth by aeration. Water from different units is collected in the retention basin or equalization tank, where oil and grease present in the water are removed by de-oiling unit. This oil and grease are coming with the compressor and pump area wash water and the drained water from the compressor and pump area unit. Then this water is sent to neutralization tank after removing the oil, where acid and caustic is added to neutralize the water. Then the pH will be maintained around 6 to 9. Based on that, we have to adjust acid dosing or caustic dosing to enable bioagent growth. In this pH around 6 to 9, the bioagent growth will be effective and wastewater treatment is effective. Then the water is sent to flocculation tank where cationic emulsion polymer flocculant is added to form flocks, and then the water is sent to flotation tank where air is mixed around 5 bar with water in a air dissolving drum to separate the lighter particles, oil and grease by reducing its density to form into flocks and is sent to recovered sludge tank. When it is water is admitted in the air dissolving drum, pressure is increased by admitting air and it is discharged where the pressure get reduced. So the lighter particle like oil and grease floats on the top of the water, which is sent to required sludge tank. Based on the influent impurities, cationic polymer is used in the flocculation tank. Now we can see the treatment overview. The overflow from the flocculation tank water is passed to the aeration tank through a wire where water is blown with the air by air blowers to provide necessary dissolved oxygen for bacterial activity. Dissolved oxygen is normally maintained between 3 to 5 for effective bacterial growth. In this aeration tank, activated sludges growth in order to remove organic pollutants. Urea and trisodium phosphate are added in this tank to wastewater to provide nutrient to bacteria, which increases the activated sludge growth. From the aeration tank, wastes are sent to the clarifier by gravity. In the clarifier, from the clarifier, clear water is overflowing from the clarifier top through air will be sent to seawater channel or outfall. The accumulated sludge will be sent to the thickener. Clarifier is a round tank equipped with a rotating peripheral rake with bottom scrapers to convey the sludge to a central sump, which recycle the activated sludge from the central sump and recycle back to the aeration tank through a pump in order to maintain the required suspended solid concentration. The floating material, if it is activated sludge is more, then is skimmed out to a container by a surface skimmer mounted on the rotating bridge at the top of the clarifier. In the clarifier tank, clarifier activated sludge is concentrated in the central sump and the level is maintained by recycling back to the aeration tank. Some of the sludge is removed to thickener and excess sludge is removed if there through surface skimmer. Clear water is sent to outfall or seawater channel. Now we can see the process. The excess sludge production is to be sent to the thickener based on SS30 result and sludge recycle result from the aeration tank and from the clarifier. Sample is collected from the aeration tank and from the clarifier. The SS30 in the aeration tank should be 180 to 250 ml in 1000 ml and in clarifier RAS should be 500 ml in 1000 ml. From the biological treatment, activated sludge is formed is sent to the thickener in order to reduce the sludge volume to be disposed from 1% to maximum 3 to 5% in the thickener. The thickener tank is equipped with the two rotary arms complete with surface and bottom blades to scrape the water surface, the bottom of the basin and to break up the sludge mass during its thickening. The activated sludge formed in the aeration tank, the SS30 is maintained around 180 to 250 by means of nutrient addition, biomass growth and RAS volume. The activated sludge is maintained around 180 to 250 means that wastewater treatment is effective. Now we can see the sludge volume index expected condition. If it is less than 100, then it is old biosolids. Possible fin flock effluent and turbidity will increase. That means that BOD and TSS are increasing. So biosolid or activated sludge growth is less. It is 100 to 250. Normally 180 to 250 means normal operation. Settling is good and perfect. Low in effluent turbidity, that is effluent turbidity is reduced TSS is reduced, so the plant is running at good condition with efficiency. If it is greater than 250, bulking biosolid. That is bulking biosolid is due to the and pore settling and higher effluent turbidity. That means if the TSS is not removed, as biosolids in the activated sludge is increased, settability is more than if it is more than settability is more than 250 in the SS30 result. The concentration of BOD in milligram per liter in the influent can be used to calculate the total BOD load per day being treated. It is simply done by multiplying the biochemical oxygen demand in milligram per liter by the daily effluent volume in cubic meters and dividing the product by 1000. kg biochemical oxygen demand per day is equal to BOD in milligram per liter into daily volume meter cube per day divided by 1000. This is the load of the influent. Based on that, we have to adjust the wastewater treatment. Food war mass loading units. kg BOD divided by kg mixed liquid sulfur solids per day. This is a food to mass ratio. It determines the degree of BOD removal likely to be achieved. Based on the FRM ratio, the BOD removal is attained. The lower the FRM loading, the greater the BOD removal efficiency. That is, if the FRM ratio is less means, then the plant is running at a normal condition with more efficiency. Typically, the FRM ratio is in the ratio of 0.05 to 0.1, results in BOD removal efficiencies of about 95 to 99%. If it is 0.1 to 0.2, then the removal efficiency will be around 90 to 95%. If it is 0.05 to zero point 0.1, then more TSS is removed and BOD also reduced, and plant is running at more efficiently. Nutrient requirement is another one. The principal nutrients which often have to be supplied in chemical form are nitrogen and phosphorus. Nitrogen through urea and phosphorus through trisodium phosphate. Both nutrients are added. The usual minimum requirement is related to the BOD of the raw wastewater influent. The ratio is 100 is to 5 is to 1. That is, BOD is 100 means then 5 nitrogen and 1 phosphorus to be added for biomass growth and activated sludge formation. Now we can see the wastewater quality at the influent and the treated water. Normally the influent BOD will be around 250 to 400, COD will be 750 to 950, and oil and grease around 60 to 130, TSS will be around 350 milligram per liter, and TDS will be 13,000. BOD and COD are in the ratio. So if it is 250 to 400, the COD will be around 150 to 9 and 950. The effluent or treated water BOD will be less than 30 milligram, or COD less than 100 to 150, and the TSS less than 30 milligram per liter, based on the activated sludge growth and the biomass growth in the aeration tank, and this is calculated by SS30 result. If it is maintained around 180 to 250, then the BOD reduction or the efficiency of the plant and the TSS reduction is achieved, and the efficiency is more. Also, the F bar M ratio is maintained between 0.5 to 0.1, 0.005 to 0.1. And oil and grease from the influent, it is coming because of oil wastewater from oily water from the compressor and pump area, and that is removed in the retention basin by means of de-oiling unit, and also removed further by in the flotation tank by in the air dissolving drum. The oil and grease will be reduced less than 10 milligram per liter in the effluent. The TDS coming in the influent will come out as such. If you want to reduce the TDS for zero liquid discharge, then we have to use ultrafiltration, nanofiltration, or membrane treatment. At the tertiary treatment, then we can reduce the TDS and we can reuse the water for further usage. pH will be around 6 to 9 by neutralizing in the nutrition tank by means of acid and caustic, so that we can use it for gardening, or even you can send it to outfall. Phenol and chromium, normally if it is less means it will come as such in the effluent itself. Hope you might have understand the activated such process used in the wastewater treatment. Please do subscribe and share it with your colleagues and friends. Do not forget to put likes and comments in the comment box. See you in the next episode. Thank you very much.